Welcome everyone. Today is best practice number 8. Up until this point, all we've talked about was about firewall policies, which is traffic that is going through the firewall to reach a specific destination. But today we're going to talk about another type of policies that exist in the FortiGate, which is very, very important for you to know. They are called local in policies. And these policies will govern all the traffic that has its destination to an interface of the firewall of the FortiGate, which means traffic that ends at the interface. For example, let's take interface 1.1, which contains your public IP. So any traffic from the internet that has a destination to your specific public IP, this traffic is governed by the local in policies, or it could be one of your internal VLANs. For example, this VLAN I have, this IP, any traffic, if I do a ping on this specific IP of my VLAN, the ping will be governed by the local in policies. And why this is important? This is going to be mainly important for our publicly exposed interfaces, such as WAN interfaces. And what we want to do is we want to do a similar thing that we have done with the firewall policies, but we want to create these policies as well for any traffic that has the destination to our WAN interface. How do we do that? We go here. It's only in CLI up to FortiOS 7.4, and when you get to FortiOS 7.6, now you can do it in graphic. But for now, we're gonna do it in CLI. So I have a bunch here, but by default, this is empty. So there's none by default. Everything is allowed. So I follow a structure to build that. What I do is I will first create an implicit deny. So you see, and this follows a hierarchical structure similar to firewall policy, top down. It's processed from top to bottom in order. So the first thing I create is implicit deny. So I say, I set my interface as 1.1, source all, destination all, service all, and by default, it's denied. So you don't see the set action deny because it's the default action. So it's blocking everything. So no one can reach my WAN. After that, I will need to allow what needs to be allowed on my WAN. So most of the time it will be for VPN. We need to allow traffic for VPN. And that's about it. So my upper rule here, so you see, I've allowed all of my AS number objects and a few other objects and the action is accept, and they are allowed to do IK, which is IPsec, and ZTNA. I only allow these two ports, and it's only allowed from these public IP addresses. Then on top of that, this is where I will put all of my blocks. So all of the denies for security. So I do the same thing as we've done with the firewall policies. So, I have one that block all the data centers and public clouds. I don't want any public clouds and data center to be able to poke at my WAN. This one is another allow because I have a few virtual machines in Azure and I needed to have them to be able to do ZTNA and IPsec. So I've done an allow before blocking all of the public cloud for my specific IPs of my VMs. Then I have other blocks. So I block all of the scanners, same objects we've used in the firewall policies. I'm going to block these good objects from WAN to LAN, from Romain Marcoux feed. I'm going to also block, same thing we've done in firewall policies, Canada and USA, with a negate, so a reverse. So everything else other than Canada, US, it's being blocked by the local in policies for WAN. So this is the structure I use. You can copy it. You can do the same thing as me, you can optimize it. And there's also this one, which it doesn't apply here. It's just that I've done some testing for non-WAN interfaces, for internal interfaces. I was doing some tests. But for today's video, it's really about focusing on the WAN, reducing your attack surface, and configuring your local in policies. This is it for today's video, and I'm gonna see you in the next one.